Hello, students, and welcome to another edition of Phillips Podcast, or P Squared. Our target for today's podcast: by the end of this podcast, you should be able to identify similar triangles. Some vocabulary words for today's podcast: congruent. Congruent shapes in math: same shape and same size. Congruent: same shape, same size. You need to recall in this podcast that every triangle has a total of 180 degrees. Every triangle has a total of 180 degrees. Our last vocabulary word for today's podcast: similar. By definition, similar shapes, same shape, different size. Similar shapes, same shape, but a different size. Lesson 5.4, we're going to look at similar triangles today. So here's one of our vocabulary words. Similar triangles. Similar, same shape, but not the same size. If we look at this example, we have two triangles, clearly the same shape, but we want to know if they are similar. Take your green numbers, write a fraction. 6 is to 3. 6 is to 3. Take your blue numbers, write a fraction or a ratio. 10 is to 5. Take your red numbers. 8 is to 4. 8 is the 4. If you're ahead of me, which is a good thing, not always a hard thing to do, but it is a good thing, you can simplify all these fractions. Each one of them, you should be able to see, will simplify to 2 over 1, which we know in math is equivalent. Nice vocabulary word, Mr. Phillips. Equivalent plus 10 bears. All these fractions or ratios are equivalent to 2 over 1, which is the same thing as 2 whole. So by definition, we can say these triangles are similar because all of their lengths, when you set up a fraction or a ratio, are equal or equivalent. Let's keep chugging to the next slide. Take a look at this example with me, guys. We want to know whether these triangles are similar. My first suggestion is that you find the missing angle in each triangle. Find the missing angle in each triangle. So for this triangle, I'm going to solve for x. In this triangle, I'm going to solve for y. If you remember from a previous podcast, the easiest way to do this is to add what you know. So I'm going to add 75 degrees and 50 degrees. That should give me a total of 125 degrees. Remember from previous podcasts, every triangle has 180 degrees. So I'm going to do 180 minus 125 degrees. When I do that, I should get an answer of 55 degrees. So for this example, x is going to equal 55 degrees. I'm going to do the same thing in this triangle. I'm going to add what I know. 50 and 55, or if you wanted to, you could use the commutative property. Nice job, Bears. Plus 10 vocab. Commutative property. You could have said 55 plus 50. In either case, that would give you a total of 105 degrees. Each triangle has 180 degrees, so I'm going to take 180 and subtract 105 from it. When I do that, I get 75 degrees. So we're going to say y is equal to 75 degrees. I'm going to take my angles and I'm going to list them out. So I have 75 degrees. I have 50 degrees. And you remember, I solved for this missing angle, so that was 55 degrees. In this triangle, List them out. I have 55 degrees, 50 degrees, and 75 degrees. Well, that's nice, Mr. Phillips, but how in the world does that help me tell if they are similar triangles? Excellent question. Plus 10 if you were thinking it. You need to ask yourself, are all the angles in the triangles the same? So I'm going to come back here and I'm going to look and I'm going to say, are all the angles in the triangles the same? So I have 75 degrees in this triangle. How about that? I got a 75 degree there. 50 degrees, 50 degrees, 55 degrees, and 55 degrees. So we should be able to see all of the angles in the triangle are the same. 75, 50, and 55. 75, 50, and 55. So if all of the angles in the triangles are the same, we say the triangles are similar. So today's podcast, your target, you need to be able to find that missing angle, list out the angles. If all of the angles in both triangles are the same, we say by definition, these triangles are similar. Remember, all the angles in both triangles are the same, so we say by definition these triangles are similar. Your study tip for this podcast: if two angles and one triangle are congruent. Nice vocabulary word, Mr. Phillips. Plus 10, plus 30 if you're counting. Not that I am. If two triangles and one triangle are congruent to two angles and another triangle, then the third angle is also congruent. So you know what this means in English? Come back up here and take a look. I have a 75 here and I have a 75 here. I have a 50 here and I have a 50 here. So by definition, two of the angles in each triangle are congruent. By definition, if two of the angles in each triangle are congruent or equal to each other, the third angle has to be congruent by definition. Next slide. All right, guys, take a look at our second example. Again, we want to know if these triangles are similar. Remember from our last example, I told you to find the missing angle in each triangle. I'm going to find X and I'm going to find Y. This will be a 90-degree angle, guys. So I have 90 degrees plus 42. When I add those together, that will give me a total of 132. Now I'm going to take 180, total degrees in a triangle, subtract 132. When I do that, that will give me an answer of 48 degrees. So I'm going to say X is 48 degrees. I'm going to do the same thing in this triangle. I have 90 degrees and 38 degrees. When I add them together, that'll give me a total of 128 degrees. 180 degrees in every triangle. 180 minus 128 equals 52 degrees. So we're going to say Y is equal to 52 degrees. Next thing I'm going to do is I'm going to list out all of my angles in the triangle. So I have 90 degrees. Sorry about that, guys. Minus 10 bears. Gotta expedite the process or the creation of those podcasting in progress signs to post on my doors. Anyways, I'm listing out all my angles. 90 degrees, 42 degrees, and my missing angle was 48 degrees. Over here, list out all my angles. 38 degrees, 90 degrees. My missing angle was 52 degrees. Remember from our last example, ask yourself, are all the angles in the triangle the same? I have a 90 degree and a 90 degree. Geez, don't see anything else that is similar or congruent. 42, no 42. 48, no 48. So by definition, because my angles are not congruent, or they're not all equal, these triangles are not similar. Not similar. They each have a 90-degree angle, but that's all they have in common. Remember, all the angles in the triangles are not the same. If all the angles in the triangles are not the same, we say they are not similar. Let's keep the train moving. Okay, now what I'd like you to do is I'd like you to pause this podcast, stop the podcast for just a minute, and either in your notes or on a scrap piece of paper, I would like you to tell whether the triangles are similar. If you work the problem correctly, you should be able to say that the triangles are not similar. So if you said they're not similar, nice job. If in this example you said they are similar, then you are. Okay, I'm going to scroll down and then I'm going to ask that you pause the podcast one more time. So we're going to pause the podcast, and you either in your notes or on a scrap piece of paper, you're going to work the problem out and you're going to tell me if these triangles are similar. If you work the problem correctly, you should be able to see that they have angles that are 90, 66, and 24. Since all of the angles in both triangles are the same, we say they are similar. If you said these were similar, if you told me these triangles were not similar, then you are. Thanks for watching today's podcast. Stay tuned for our next podcast on indirect measurement. Nice vocab, Bears plus 10. Later.